everyone out there. Welcome to Solve It Out. This is Annie here, and today I'm going to solve a LeetCode question, that is a merge sorted array. This is an easy question, but I think the approach how it is solved is quite there to understand. Now, the question says that we have two arrays, nums1 and nums2, and sorting that in already sorted, it is in non-decreasing order, and we have to merge it. So in JavaScript, what we do, that when we are merging it, we can easily concatenate and then sort it out if we want to merge it and then sort it. So we can do that easy, but here is the trick of the question is, the final sorted array should not be returned by the function, but instead to be stored inside the array nums1. That means it should be like in place, like merging should be done along with the sorting. So here you can see a input nums1 already. If the length of the two arrays are taken in the nums1, and this is the nums1 main like actual length, and this is the nums2 length, and the output should be in a sorted manner. So let's check how we can approach this solution. So here I have taken the nums1 array of size m and nums2 array of size n. Now the brute force approach, as I was discussing, is that if we concat and then do the sorting, it will show for concatenation our time complexity will be on, and for sorting our time complexity will be on log n, using the normal array dot sort. Here, so specifically here, we will have the time complexity, like as the nums1 array is m plus n, as you can see that this array is m here, like this nums1 consists the size of m plus n. So what will be our the final time complexity for the brute force approach? It will be tc big of m plus n log m plus n, isn't it? Okay, and what will be our space complexity? Our space complexity will be big of m plus n, like what we take it as n. But this should not happen, because the constraint in the approach, like in the question, was we have to solve it like stored it inside the array 1, like in place sorting should be present. So there, how to approach it? One approach that we can do, I think that's the most optimal approach here, is that the pointer approach. What's the pointer approach? Here we are going to take up 3 pointers, like, and where we should put the pointers, that's also an important thing. So we are going to take p1, p2 and p3. Okay, so in this pointers, what we are going to do is that p1 pointer should be at the m minus 1 index, and p2 pointer should be at n minus 1 index, and p3 pointer should be at m plus n minus 1 position. Why? Because here, if we take up the array here, let me just move this point. Yes, if we see the array here now, we will see that one pointer, that is our p1, should be put here at level 3, because this is our size m, and we are going to put the pointer at m minus 1 position. And then our next pointer, that is p2, should be put here, because that's the size of our n. And the p pointer, or you can say I have named it here as p3, we should put it in the last of this array, because we are going to put we are going to add up in the same nums1 array as we are doing in place sorting, also merging. So like this way, if we put the pointer, and then what we should do is that we should check like whether the value of p2 and value of p1, which is bigger, like whether p2 value is bigger or p1 value is bigger. According to that, what we should do, we should update the value of p pointer or p3 pointer. Okay, so that what will happen is that we will do the merging and sorting together. The time complexity will come down to O n plus m, because as we are using the in-place sorting, it will reach down from n log n to O n, and as it is the array nums1 consists both n plus m, so it will be O n plus m. And what will be the space complexity? Space complexity will be just O1, as we are not using any of the extra space to do the sorting. So I hope the initial concept is clear. Let me code it down, then you like the JavaScript code, then it will be more easier to understand. So here we are going to take 3 pointers at first. Let p1 is equal to m minus 1 at the last of this like nums1 actual array, and let p2 will point at n minus 1, that is on the nums2 ending position, and let p3, and taking at p here, so p will point at m plus n minus 1 position, that is this whole array, this is the last index. Now what we are going to do is that we'll take a while loop. Here we'll check that if the pointers are of course greater than 0, and then we'll compare the value. Put a if condition here, and we'll check if nums1 p1 is greater than nums2 p2. Then we'll assign the nums1 p value to the nums1 p1 value, and p1 will decrease the pointer. If the nums1 p, like the nums1 p1 value is greater than the compared second second array, then in the nums1 last position we'll assign this current value, and also will decrease the p1 pointer with minus minus. Taking else here, else what going to do, just copy it, and it will be just the vice versa, that is nums1 p value will now have the nums2 p2 pointer value, and the p2 pointer will be decreased, because now this one, like the nums2 p2 pointer value is now greater, so there will decrease that pointer. Finally, after this if else, we are going to decrease the main pointer of ours, so that for if like for one this ending point is done, and then we are decreasing the counter value pointer to this position, we're moving to the second last position. Then one thing to check more here is that if check like m and n is of course different, so if n value you find it out that yes, there are more like numbers left compared after comparing with the m value, that means p1 pointer ended up but p2 pointer is still left, then what we should do? For that we will run another while loop. This is an edge case where we'll check that p2 pointer is still greater than 0 or not. Okay, so that time we'll assign nums1 p to nums2 p2. Okay, and then we'll do p2 minus minus and p minus minus. So this is where we will just compare it and just assign the values to it and decrement the counter. So this is just an edge case, and here we'll run it. You see that it's accepted in and runtime is just 0 millisecond, and we'll submit. Yes, it's solved in 0 millisecond and it's 100%. So yeah, though this is an easy question, but it still needs some pointer knowledge. So thought to share with you guys. That's it for today. Take care. Bye bye.